Hi guys, welcome to this set of videos. What we're going to do here in this section of notes and in this set of videos is now we're going to use this same idea that we've been talking about where we can write proportions for similar triangles. We're going to keep the proportion idea and kind of set aside the triangles for a second. And what we're going to do is look at how you would divide a line segment into a certain ratio, all right? So we're gonna keep talking about this idea of proportions and ratios. Set aside the whole triangle part of it for a minute and just take a look at a line segment. So here's what we're gonna do. Our essential question is this: how do you find a point on a directed line segment that partitions, meaning the point will partition the given line segment into a given ratio. So it's just simply this: if I give you a line segment and I want you to divide that line segment into two parts. One part is 2/3 and the other part is 1/3. How do you do that? Or I give you a line segment and I want you to divide that line segment where one part is 3/4 and the other part is 1/4. How do you do it, right? That's exactly what we're going to be talking about here. I'm going to give you a line segment. I'm going to tell you how I want that line segment divided. I want to take a look at how we're going to go ahead and do that. The way that we'll do this is simply by having you guys take a look at partitioning segments on a number line. So we're going to start off easy, just a straight line, a number line. That's the easiest way. And then we're going to go a little bit more complicated where we're taking a look at directed line segments on a coordinate plane. All right? So we'll start off with the easy one, and then we'll work our way up to slightly trickier as we go. Let's just jump right into this with the easy one. First, I'm going to give you a direction here or tell you how to do it that's really listen, you guys run into this all the time in math. Verbally, the way that we explain how to do something and then the way it's actually done, while they mean the exact same thing, actually seeing it is always easier than reading it. And here's another case. The way that we're going to do this is we're going to write a ratio. Oh, sorry, I want my highlighter not moving it. There we go. We're going to write a ratio for how you would like to partition this segment and multiply by the absolute value of the difference between the endpoints of the segment. Dude, say what? Yeah. So I know, as far as the words go explaining how to do it, it seems complicated. It's not. Here's what we've got. I have given you guys a number line. Here's what I want you to do. I'd like you to find the coordinates of a point P. So we're going to find this point P. Now, how do I know where P is going to be? Right here. That partitions A to C, so we're going to go from A to C. I want you to divide that line segment from A to C so that it is by a ratio of 2 to 1. Okay, well, here we go. I know I'm going to go from A to C. So let's figure out where those guys are on the number line. Here's 10, 11, 12, 13, 14. So A is at 14. What about C? Well, here's 40, 41, 42, 43. C is at 44. So, here we go. This line segment right here, this is the line segment A to C, that guy right there in red. I want you to partition that line segment into a ratio of 2 to 1. And we'll know that ratio by finding the point P. That splits that line segment into a ratio of 2 to 1. All right, well, according to my directions, the first thing I need to do is I need to write a ratio. So let's just quickly here for a second remember what a ratio is. A ratio is simply going to be a ratio is represented by a fraction, right, where the numerator is the part that you want and the denominator represents the whole, right? So if I only want 1/8 a piece, 1/8 of a pizza, right? You would cut the pizza into 8 parts. 1/8 of it would just be one slice, right? So I want 1/8. I want one piece out of the total number of pieces, which would be 8. I have 8 pieces of pizza and I only want one of them. If I want 2/8 of the pizza, you would give me 2 pieces, right, of the 8, right? So that's what we're doing here. A ratio is simply going to be the part that we want over the whole. Okay, well, here we go. I want 2 parts to 1. Now, hang on a second. I know that that seems careful. The way that I have it written, we now need to write it as a ratio. How many parts are there? Well, there's 2 parts here, 1 part here. Wait a second, I know, you just got confused. I thought it was the part over the whole. That's what you have to write. Look, the directions say you need to write a ratio based on the proportion, right? So we're going to split this line segment so that I have 2 parts to 1 part. Okay, so here we go. I want 2 parts. What is the whole? Well, if I have 2 parts and 1 part, in order to get the whole, I got to put all the parts together. 2 plus 1 is 3. So the whole, 2 plus 1, 2/3. So the way that this is going to work out, a ratio of 2 to 1 is simply going to be 2/3, right? 2/3 of the way. Okay, well now, how do I do that? Well, that's where the rest of it comes in then. We will do that by multiplying the ratio by the absolute value of the difference between the endpoints. Okay, here we go. My endpoints are A and C. So we'll take the absolute value of their distance. C is 44. A is 14. So we'll do 44 minus 14, take the absolute value just in case that number winds up being negative. In this case it doesn't. You wind up with 30. 44 minus 14 is 30. So there we go. I've written my ratio. Here it is right here. The part that I want, 2, over the whole. Add all the parts together. 2 parts, 1 part, add them together, that's 3 parts, that's my whole. So here's my ratio. I just found the absolute value, the difference between the endpoints. What do the directions tell you to do? Tell you to multiply them together. So the point P is going to be 2/3 of 30. Well, this isn't that bad. 2 times 30, 60. 60 divided by 3 is 20. I'm sorry. Equal, oh, I'm squeezing. Let me slide this over. I didn't leave myself enough space. P, we're going to do 2/3 times 30, which is 20. Okay, now let's find, right, where is that point P? Okay, here we go. Well, I know that I need to, right, starting at A, to get my 2 parts, I need to go 20 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Woo! 20 spaces. It's right there. So point P is actually point B. Actually, here, what is that? Let me go ahead and give you that value. That is equal to, let's see, what is that? 31, 2, 3, 34. Okay, that's how it works. Let's try another one just to make sure you're okay with it. I'll slide up here just a little bit because I still need to be able to see my number line. There we go. That should be enough scooting. Okay, so again, right, we start by setting up the ratio. I want you to find a point P that partitions A to C, so it's the exact same line segment, A to C, partitions A to C by a ratio of 2 to 3. A ratio of 2 to 3. Well, let's write the ratio. Again, it'll be the part over the whole. Well, that's going to be 2 over 2 plus 3, which is 2/5. Well, we already know AC, right? We calculated it up here. AC is 30. It didn't change. It's still 14 and 44. So here we go. Point P, let's find it. Point P is going to be 2/5 of 30. All right, well, 2 times 3 is still 60. 60 divided by 5, however, is going to be 12. So, let's find point P. Here we go. Do it in green this time. Here's 14. I got to add 12 to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, it's point D. Right there. So point P is equal to point D, which is at the point 21, 2, 3, 4, 5, 26. All right, so there we go. That's how we're now taking this idea of ratios and proportions, and we're dividing a line segment into a given ratio. I will always have to give you the ratio. You'll then need to go ahead and set up the ratio so that you've got it written as a fraction, right? And then you'll just multiply it by the absolute value, the length of the line segment. That'll let you know where you've got to put that partition point, where you got to put that point P. What we'll do on the next page of the notes is take a look at what happens instead of having a straight line, if I have a directed line segment on a coordinate plane. Same idea, just a few extra steps. I'll meet you guys on the next page of the notes.